All right, so I know that I'm not here, but I still need you to make sure that you fill out your notes and that we go through these next two sections because you all are very behind. So pay attention, and whatever you don't understand, I will help you with on Friday when I come back. But do your best to try to get it today. So starting with the end behavior of graphs of polynomials. So this little yellow paper, which is in the basket by the door, if you didn't get one already, this is like your cheat sheet about how to do all of this, okay? This is everything you need to know right here, okay? So I'm going to show you how it works, okay? So this is going to help you predict the end behavior of graphs of polynomials. So what that means, like when you look at this first one, how it says 2x cubed, when you look at the cubed, that right there, that's the degree. So you tell me, is 3 is it an odd number or an even number? Hopefully you said it's odd because 3 is an odd number. So it's odd for the degree. And then you look at the number in front or the coefficient of that, okay? So the coefficient is 2. Now tell me, is 2 positive or is it negative? You should pick positive. Okay, so because it's positive and odd, that tells you that the end parts of your graph, like if you split this, that means the left side of your graph should be going or falling down, and the right side of your graph should be rising. So it should fall left, rise right. So when you look at your graph, it does follow those rules. It falls to the left and rises to the right. And write that on your graph so you remember. It rises right, falls left. Now we talked about another way to figure out or how to write what this means. So remember, when x goes towards positive infinity, y, or this is negative infinity side, sorry. So as y, or as x is going to negative infinity, y is also going to negative infinity because it's falling down. Now on this side, as x is going towards positive infinity, so is y. Because it's rising, it's going up. Okay, so now you can do the same thing with the next one. Okay, so look at the exponent, look at the degree, and figure out, is it odd or even? Hopefully you know that 2 is an even number. And then when you look at the 3, the coefficient, identify, is it positive or is it negative? So is it a positive 3 or a negative 3? And this one is positive. So this time we're looking at a positive even degree. So that means it should be rising on the left and the right side. So it should be increasing on both sides, which is what our graph is doing. It's rising on the left, rising on the right. So you put rise, left, rise, right. Okay. And again, we figured out how to write that with infinities last week. So as x is approaching negative infinity, so as x is going down, y is going up because it was rising. Okay, now as x is going towards positive infinity or going to the right, y is rising, so it's going to positive infinity. Okay, we're going to do the exact same thing with c and d. Just looking at c and d. Hopefully it'll focus. Give it a second. There we go. We're going to do the exact same thing here. So again, look at the exponent. Look at the degree. Is that positive, or is that even, or is that odd? Hopefully you know any multiple of 2 is even. And then look at the number. Okay? Now, is there an actual number written there? No. But it has a negative sign, which means it's a negative 1. So that means your coefficient is a negative coefficient. So we need negative and even. So negative and even, it means both sides of your graph are falling. So it falls left, because it's going down, and it falls right, again, because it's going down. Okay, and again, how to write that with your infinities. As x is going towards negative infinity on the left side, y is also going towards negative infinity because it's falling. As x is going towards positive infinity on the right, as it goes to the right, y is going towards negative infinity because our line was going down. Okay. All right, same thing on this one. Okay. Look at your exponent. Look at the degree. Is that odd or is that even? You should be able to tell me that it's odd. Okay. Now the coefficient. Now some of you might think that the coefficient is this -1. A bunch of other kids in my other classes told me that, but it's not. It's the number in front of here. So, Ms. Howell, there's no number in there. Remember, it can have an invisible 1, and that 1 is positive. So we're looking at a positive odd degree. So positive and odd, it means your line should be decreasing on the left or falling to the left and rising to the right. So again, fall, left, rise, right. And this should hopefully look familiar because you've already done a problem like this. Part A was the exact same, so we're just going to copy down the same infinities. As x goes towards negative infinity, y is also going towards negative infinity because it's falling. As x goes towards positive infinity, y is also going towards positive infinity. Okay? So again, that's just the basics. All you're doing is you're figuring out which way does a graph go based off of the leading coefficient or the number in front of your highest exponent. Okay? So that's what we're going to do. We're going to do it about 10 more times. Okay? So this next one is a fill in the blank. I want you to tell me as x is going to positive infinity and y is going towards negative infinity. Think about it. Would that mean your graph is rising or is it falling? So if you're stuck, look over here on these first 4 graphs that we did. Where do you see x going to infinity and y going towards negative infinity? So if you're looking, I want you to find this over here. Where do you see x infinity, y negative infinity? You should see it here, right? So that means our graph is going to be falling to the right. Now find the other one. As x is going towards negative infinity, y is going towards negative infinity. So where do you see that? See if it's on this other side. Oh, look at that. It is. So that means it's falling to the left. So I want you to tell me what are the words for a double fall, where it's falling on both sides. So falling on both sides was right here. So that means it was even and negative. So your leading coefficient is negative, and the exponent is even. Okay? So all you gotta do is fill in the blanks. Okay? All right, now we're going to do this very fun and exciting graph that I'm sure you're all excited about. Okay? I want you to figure out, like looking at that graph, like you see how on here, how it has the arrows? Find the arrows on the graph, okay? Highlight them or circle them or whatever you need to do. Okay, so we have an arrow here. We have an arrow there. So on your little yellow cheat sheet, right, where do you see something like that? Tell me, what is it? Write it on your paper. Okay, you should see that it's an odd degree and a positive coefficient. So that's what you're going to put here. It was an odd degree and a positive coefficient. So if you want to go through and explain it, you can. I'm not going to because I gave you a cheat sheet. Or you can always watch Algebra Nation to figure it out if you'd like. But that's all you needed to do. Okay? All right. Next page. All right. Now, so far, they've been giving us graphs to do all of this. But now they didn't, okay? So those are the two kinds of problems you're gonna see when they give you a graph and when they don't. So this is what you have to look for when they don't give you one, okay? So see this little part in your cheat sheet, how it says the sign of the leading coefficient? That word right there, leading, is very important. Leading means it's the number that is in front of the whole problem, okay? And now there's only one catch to it, okay? You need to look for the highest exponent. Okay, that's the key here. Wherever the highest exponent is, that's your leading coefficient. Because remember from way, way back when, to put this in like true actual form, this should go in order from biggest exponent to smallest exponent. But as you can see, it's not in order. Okay? So what you should be looking for is this part right here, that x to the 5th power. That's the one we're looking for. So when you look at the 5, right, 5 is odd, and it's got a plus sign, so it means it's positive. Okay, so if it's odd and positive, okay, it seems to be a favorite one here. So odd and positive, it should fall left, rise right. Okay, so as x is approaching positive infinity, what you need to remember, is this the left side or is this the right side? So think about it. Which way are positive infinity on your graph? Is it the left or is it the right? Hopefully you know it's your right side. So if it's your right side, then that's the side that it should be rising, which means that your negative side should be the falling. Because that's what we said it was going to do. It was going to fall on the left, rise on the right. So if it's rising, that means f of x, and this is the same thing as y, by the way. It's the exact same thing. Should be going towards positive infinity, and f of x should be going towards negative infinity. Okay, and that's all they want you to figure out. Okay, now you're going to do the exact same here for number 6, only I'm not going to tell you. I want you to do number 6 on your own, and I will be checking it when I come back on Friday. Okay, so again, make sure you follow this rule, looking for the highest exponent, and use your little table and pick an answer. Okay, so if you need to, pause the video and figure it out, and then hit play when you're ready to come back so we can start the next section.